Hello, welcome back to the Music Knowledge YouTube channel. How are you today? How's family? How's life? How's academics going? Right. So welcome back to this channel once again. In our lesson today, we'll be looking at the concept of standard deviation. We'll be looking at a couple of things. Please don't jump out yet and don't look at the time of the class. Right. You're going to be learning a lot of things. Right. And then you are going to be having a take-home assignment as we are used to doing. So standard deviation is one of the measures of dispersion, otherwise known as the measure of spread or the measure of duration, right? So it has other family members. So you have the mean deviation, you have the variance, and you have the quartiles, it's like that. So in our previous class, we discussed mean deviation, discussed the concept of quartiles, we discussed the concept of percentiles and deciles, right? So in this class, I want to look at the concept of standard, deviation. So we're looking at standard deviation with a mean, right? The actual mean, like the true mean of a given data. Then we're also going to be looking at the standard deviation using an assumed mean, right? And then we're also going to be looking at the standard deviation how standard deviation can be used to identify an outlier in a given data set. So we're looking at a few things. So you just keep enjoying yourself. What exactly is standard deviation written on the board? So it is the square root, of the averages of the squared differences from the mean. So it is the square root, right, or you can just say root, right? Okay, let's say square root anyways, because you could have a cube root and all of that. So it is the square root, of the averages of the square differences from the mean, or maybe about the mean, or maybe around the mean, right? So you have this symbol used to represent it. So when it is squared, then you have it become a variance, right? So this for a population standard deviation, you have the symbol. For a sample standard deviation, it's just a small letter S, right? But if the question doesn't really state the difference, depending on the textbook that you're using anyway. So they could be using this, they could be using the other one. All right. So what I'm just trying to let you know, if it's a sample, you have S, just small letter S representing your standard deviation, and then if it is for a population in the entire data set of a given variable, then you're going to be having this. I don't know what it's called, right? Anyway, so again, standard deviation is the square root, of the averages of the square differences from the mean. And then while the mean deviation is just the average of the absolute differences, right, between data points and the mean. Now, this is the mean. Recall this formula for mean deviation. This slanted lines means absolute figures. So we are looking at the absolute figures of difference between um, a data set like an observation. We've done the x can have like a lot of numbers. So you can have x1, x2, x3. So the first value for x is 25, first value for second value 20. All of those that we used to, for example, here now, you have 11 numbers. So the observation, everything is like x, right? So this is x1, the first x number, the first observation, x2, x3, x4, x5, up to 11. So that's what we're saying. So anyways, we are looking at this slanted line means absolute figures. So which means that by the time you are doing your deviation, we are not interested in the ones that have negative signs, right? So when we did those examples in the previous lesson, we realized that we had to create a different column for the absolute deviations. So where we eliminated the minus signs, right? So that is what this stuff is essentially saying, that it is the average, that is, you're taking the mean, right? You're taking the mean of the absolute deviations of a given set of data from the mean, right? So that's about that. So you just understand the difference. Now for standard deviation, once you know this formula for mean deviation, you know the formula for standard deviation. So let me just use because except you if you're using a sample, right, n minus 1, like your frequency, sum of frequency should be n minus 1. But in statistics, except it gets to that point where you're actually told to do that, I just use n. Do you understand? Just use n. So, or sum of f, don't subtract anyone from it. Now, standard deviation formula, s is going to be equal to sum of f. Now, we are not looking at absolute values of standard deviation, so we can just do that is x minus, no, x, like observation x minus the mean of the entire observation minus by x, right? Everything divided by sum of f. Then you square this. When you square this, what you are getting is your variance, and then when you root it, what I get is your standard deviation. So look at this again. Standard deviation is the square root of the averages. This is an average, averages of the square differences from the mean. You got s minus by x squared. So of the square differences from the mean, and that's that. So our mean division is just this particular guy. So once I solve this question, in an undergraduate econometrics course, students obtained the following grades. So what are the grades? Let me just do this here. So what are the grades? We have these grades here. So I want to like create a column for it. So I will solve it without using a column, but it makes sense to actually have a frequency distribution for it. So let's go. X. Remember that I've got to rearrange. So I have X, and then I have frequency. So when I rearrange in an ascending order, so I have 35, 49, 49, 50, 52, 55, 58, 61, 63, and 96. And then what are their frequencies? Okay, when you look at 35, it's only one number like 35. So you have 1, followed by 1, 1. I think all of them are 1, except 58 and 61. 1, 1, 1, 1, 1. 58 is 2, 61 is 2, then 1, 1. So sum of frequency 1 plus 1, 2, 4, 6, 7, 8, 9, 10, 11. So sum of frequency is 11. Alright, so what else do I need? I need my mean. We need the mean. So how are we going to get the mean? We need to find our fx. Fx. So 35 times 1 is 35. 49 times 1 is 49. 50, 52. 55. It should be 116. 1, 2, 2, 63, 96. Okay, let me verify. Is it 116, 122? Okay, 63, 96. So when we're done, we get 638. 638. Okay, so then our mean, which is our bar x, equals 638 divided by 11, and that's going to give us 58. 58. So yeah, and let's do our x minus bar x. So x minus bar x. So when we do that, 35 minus 58, that's minus 23. 35 minus 58, that's minus 23. 49 minus 58, that's minus 9. 50 minus 58, that's minus 8. 52 minus 58, minus 6. 55 minus 58, minus 3. Then 58 minus 58, that should be 0. 61 minus 58, 3. 63 minus 5. 96 minus 58, that's like 38. 38. Okay, so let's verify. 23, 9, 8, 6, 3, 0, 3, 5, and 38. Alright. Is that where we're going? No, this should be capital X. Like is the observation X minus bar X. Like observation X minus the mean by X. Alright. So we need to square it before then multiply by the frequency. So X minus bar X square. So I begin to square, just put in the values there so you can use your calculator to like cross check. 529, 529, 81, 64, 36, 909, 25, 38 squared. That's 1444, 1444. Is that all? No. Then we need to go and get our f times, so f x minus by x squared, right? So when we begin to multiply, to give us almost the same thing though. 529 times 1 is 529. 81 times 1, right properly, is 81. 64 times 1 is 64. 36. 36. 9. So 0 times 2, 0. 9 times 2, 18. Then 25. Then 1, 4, 4, 4. So let's cross check. 529, 81, 64, 36, 9, 0, 18, 25. Yeah. So doing that, we are going to be having 2206, 2206. So now this is our sum of frequency of this of the square deviations of this particular data set. And then because we're done with that, so we can find our deviation, standard deviation, which is going to be equal to 2206 divided by sum of frequency 11. So standard deviation is oh okay, square root. Uh, so standard deviation is going to give us 14.16. 14.16. Yeah. So that's it. So we've got this standard deviation. Now says that we should identify the outlier. Now there is a scope. There is a method that we can use to identify the outlier. So for us to know, like pretty much looking at this thing, there's an outlier. Why? Because all the students kind of have average scores, but there is this student here that scored almost everything. Right? So it's kind of obvious that's an outlier that should be eliminated from the set. Now look at the others too. Every other person passed, like every other person scored above 50, except this person. So maybe this guy was not even really coming to class, right? And then this one just happens to be an extremely intelligent student, student with a very high IQ. Or maybe the student happens to have done the course before, right? Because there are students that would have had a degree, maybe in maths or had a degree in stats, and then they come and pursue another degree. So those things that others are learning afresh, they've learned them before, they master them, and so you subjecting them to the same kind of exam is like subjecting me to maybe 100 level, 200 level, or even a 300 level paper as I am right now. I would likely do very, very well. Okay, whether the class was effectively taught or not, because I've learned it before and I've been used to it, right? So I'm going to have one resource that is not kind of reflective of the understanding of the other students in that particular course, something like that, right? So how do we now like figure this out using standard deviation? Now for a normal distribution, right? Um, there's something about the mean and the standard deviation. So let's draw. At least we are used to the frequency polygon. Um, let me draw a normal distribution. Oh, tried. All right. Of course, the mean is equal to the mode is equal to the median. Blah blah blah. Okay. So let's put it here. So this is mean, and this is population mean, right? If you are just mean, do you understand? Now for a normal distribution, um, this guy, 68% of the entire observations, right, is going to be within is going to be within one standard deviation of the mean. Now what does it mean? Let's do this. Something like this. Something like this. So we are saying that coming to this side is positive. So we are saying that this is going to be u plus 1, u plus 1 standard deviation, and this is going to be u minus 1 standard deviation. So what we are trying to say is that 68% of the entire data set of the observation is going to fall within one standard deviation of the mean. That is, just add one standard deviation. Remember when we calculated mean deviation that we did mean plus one mean deviation, two mean deviation, three mean deviation, something like that we're also doing here. Right? Just that there is something about that when it comes to standard deviation that if your distribution is normal, right? So 68% of your entire data set will fall within one standard deviation of the mean. And then when you're now done with that, so we kind of extend it to like this kind of parts. Now this is going to be two standard deviation away from the mean. So you have u minus 2 SD, standard deviation away from the mean. And then this guy here is u plus 2 SD. So within that range, that's 95% of your observations. Like it is standard, like 95% of the observations is within the range of is within two standard deviation from the mean, right? 95% of the observations. So you may now have this one when you come to the tail. So here you're having u minus 3 SD, and then here, like this tail, so I'm having u plus 3 standard deviation. So for that one, right? So from here to this part, 99.75%. So again, it is standard, right, in statistics. Now, okay, 68% of the observation is within one standard deviation um, away from is one standard deviation away from the mean, like whether to the positive side or to the negative side of the mean. Then 95% of your data set, your data observation will lie between two standard deviations, from the mean, and then 99.75% of data sets will lie between three standard deviation of the mean. So once this for a normal distribution, right? So by the time you want to like test for an outlier, once once a data set, or once a data point, right, is lying outside of true standard deviation from the mean, right? So you have to investigate it. It is likely going to be an outlier. So once you have a data set that is two standard deviation, look, it's already like getting outside of two standard deviation of the from the mean, right? It is like pretty much far away. And that's the point, like pretty much far away from the mean. So what do we do? Or how do we like kind of apply that to what we're doing here? Now we've gotten our standard deviation here as 14.16, right? And we've gotten our mean as 58. So let's do two standard deviation away from the mean. Okay, let's start with one standard deviation away from the mean first. So we have u plus one uh, standard deviation. I'm just how would I even put it here? Okay, I'm just ST, right, from the mean. So u is so that will be, it means plus or minus rather. Uh, Plus or minus, yes, plus and minus here. So we have 58 plus or minus 14.16. So what range are we going to be having? I think I've done it already. So that should be 72.16. So we're having 43.84 to 72.16. Then u plus or minus 2, no, plus or minus 2 standard deviation from the mean. That's 58 plus or minus 2 into bracket 14.16. Remember, just the exact way we did um, for mean deviation then. So when we do that, we are going to be having 29.68. So this is going to be, okay, let me write it down. 58, for example, let me just write the one for plus 2 into bracket this, that's going to be 28.32. So when you add it up, this is looking like an 86.32. Do you have that value? Yes, this is 86.32. You can do the same thing. 58 minus 3. Sorry, 58 minus 2. So it's going to be 58 minus 28.32. And then this guy is going to give us what was it? 29.68. 29.68. So which means that the interval for that will be 29.68 to 86.32. So we can just draw a line. So I could just do this. So where the mean was 58. Where the mean is 58. So plus one standard deviation away from the mean, we got where is it? 43.4, 72.16. I could just 72, at least for this data set, 72.16. Then this side, 43.84. Then the one that is two standard deviation away from the mean, 29.63. 29.63. Then here, 86.32. So anything that now kind of falls outside of all of this is likely going to be um, an outlier. So if you look at it, what values? 96 is after two standard deviation. So 96 is like maybe here, 96. So that's an outlier. Uh, 35, 49. 49 is still within one standard deviation, like between 58 and it's not even against 43. So yeah, still fine. 35, okay. 35 is more than one deviation away from the mean. Okay, still manageable. At least this guy 96 is two standard. So investigate 96, right? So it is best to eliminate 96 from your data set, because if you don't, right, it's going to give you a wrong reflection of your data set. So it will be looking as if students did better than they actually did. So remove 96. So let us know that everybody got an average score, on the exam, right? So don't use that one person to judge entire the entire class. All right, so there is this other thing that I want to also talk about before we now move into a different part of standard deviation, because all of this one is about our group data. Yeah, so what is statistical score? So we can also use statistical score, or what we call the Z score, to um, talk about the kind of what do you call it now? Can use it to talk about, we can use z-score, because z-score makes use of standard deviation, so we can use our z-score to also say something about our data set. Like, let's try and see one example. So standardized variables and standardized scores rather. So the variable that is used to measure the deviation from the mean in units of the standard deviation is known as a standardized variable. So you have a value, but you are trying to like measure it in relation to the standard deviation of a given data set. So we are saying that you are trying to generate a standardized variable. So here the value that you're trying to express in terms of standard deviation, that gives you a standardized variable. Right, so there's something that we call standardized scores or standard scores or Z scores, right? In statistics, in the world of statistics, and the formula is simply your data sets, all right, minus the mean of that data set divided by the deviation of the data set. So if this were to be a population um, standard score, for example, now is that x minus u is the mean, that we're using for the population, then s would have been that sign, gamma, whatever it is called. Okay, so now let us look at the application of a standardized score to interpret something. Now, there is Wisdom. Wisdom is one of our students right now in 20 level. So, Wisdom received a grade of 84 in Echo 204 with a class mean average of 76. So, on average, students got 76 in the class, and then he got 84, right? And SD of 10, standard deviation of 10. Now, he also scored 90 in Echo 201 with a mean grade of 82 and a standard deviation of 16. So in which case was his relative standing higher? So just looking at this, what's his business? So his business is going to be, I got 90 in Echo 201. So he must be feeling fly. That, okay, 19 equal to that's amazing, that's lovely. But let us look at the standard scores. Like, is that really what it is? Right? Should it be that like was 90 easier to get in Echo 201 compared to the 84 that he got in Echo 204? Do you understand? So like that's what we want to do now. So for the first one, for the first course, so the Z score, Z equals X was his own score was 84, that's average of, so you have 84 minus 76 divided by 10. And this is going to give us 8 over 10. Abi? So that's will be 0.8. This is 0.8. Now for the second one, Z equals 90 minus class average of 82 and divided by 16. 8 over 16, right? And then that will be 0.5. So his relative standing was higher here, where he got 84, than it was when he got 90. That's interpretation. So on average, it did better, right, compared to the class. Do you understand? In Echo 204 than Echo 201. So it was harder to get an 84 in Echo 204 rather than in Echo 201. So like that's just what we've done here. So yeah, and this will bring us to the end of this particular lesson. So we have assignments, and then we are going to be looking at assuming and standard deviation of a group data and whatever else that we need to like look at in that particular lesson. So thank you. See you there. Hi. So here's the assignment. We have two students, Ego and Chion. Both footballers in this example, but in this assignment, we happen to be 12 our students. So they're in a tournament. So you find out how many games that they played, and then look at the goal scored. So in some of the games, they scored no goal, one goal, two goals, whatever. Now, for Ebon, 12 times no goals, 8 times one goal. So 12, 8, 8, 1, 1. That's what she had. That's figure. Therefore, Sheung 4, 21, 5, 0, 0. So your question again 4, 21, 5, 0, 0. So your question now is find the mean and the standard deviation of the goals each player scored. Then number two, comment on each player's goal scoring records. So hints, at least interpret with respect to Q1. At least interpret with respect to your mean and the standard deviation. You may also look at it's kind of an applied question. So you look at the range, etc. like that. Now number three, who was the better goal scorer, or who are you gonna have on your team, right, between Sheung and Ekun? So thank you. See you in next lesson. Bye.